So you made it to part four, all the way to part four of my discussion on the constant flow mechanical fuel injection. Welcome back. Um, we've gone through a number of items to discuss, all the way from the beginning, setting up the butterflies and the linkage and the leak down test of the barrel valve. Um, Now, and I showed you some nozzles. We talked about nozzles a little bit, and also a pump, one of the fuel pumps. So now it's ready to talk. I'm ready to talk about the high-speed bypass and the main pill holder. I've had a number of people, questioning, when are you going to get to that? And I want to know how to tune the system. Um, I'm going to show you in a second here the system itself on the front of the motor, so it makes a little bit more sense of how things are plumbed. It's kind of a mess, but I'll try and walk you through it. And then I actually put together a couple little schematics on a PowerPoint, which I'll click through and explain what everything is doing. And then after that, I'm going to take apart the main pill holder and the high-speed bypass and show you how that's configured, how those things work. So that's what I got today. This is, I said, this is segment number 4, I guess. I'm going to have one more where I've got a little clip of my visit to the Gator Nationals. We actually got an opportunity to go through one of the funny car team's trailers, which was kind of interesting. So I got a little clip. I'm going to show that the next time. I think that's going to be the last one. That's going to be segment number 5. And then I'm going to show you some software that's free for you to use that'll help you do your tune on your constant flow system. So anyways, we're going to get right into it and start talking about the main bypass, or the main pill holder and the high-speed bypass. So here we go. So now it's time to take a look at the pump and the configuration. Now when you look at this, the first thing that comes to mind is like, wow, what a mess of lines and such. But it's really not that bad. So you can see here, this is the pump. This is the Waterman pump we were talking about. This here is just back here. That's just an extension, which gives me clearance for the belt I use to run a vacuum pump on the crankcase. So there's the pump. Now you look on this side. There's those 2 brass cans we were talking about, right? That look just like the idle bypass. We got 2 more. There's this guy here, and then there's this one here, which I have a yellow band on. The one with the yellow band is my main pill. That's the one that you're really going to be concentrating on when you're tuning your system. That is what restricts the flow back from the pump, from the pressurized. Well, so let me go back. So the top of this pump, you see these 3 outputs. They're all connected together. That's the output of the pump. So all 3 of those fittings have the source fuel right from the output of the pump. So they're all equal in pressure. So we're just, now this top line here, this just goes up, goes through, I got a 35 micron filter here, sintered bronze filter. Then it goes up to my shutoff valve and then to the barrel valve. But, so getting back to these cans here now, though, the one with the yellow band, that's my main. So that's what holds the main pill. And we're going to talk about that. I'm going to take this apart and show it to you here in a little bit. Now on this side here, this one here is your high-speed bypass. Let me see if I can get a little better angle on it. This is the high-speed bypass. And what the high-speed bypass is used for is to alter the fuel curve when you're at really high RPM. If you've looked at a fuel curve on any naturally aspirated engine, as you increase in RPM, the actual need for fuel goes down. And the reason for that is due to a thing called the volumetric efficiency of your engine. And I'm going to talk about that a little bit too, because I think that's something that needs to be addressed. So those are the other 2 factors that we use, that high-speed bypass. And some of these are actually you know, this just has a spring in there and it's set. I'll have to check it. I don't actually even remember anymore. But it's set at about 100 psi. And then there's also a pill in there which restricts the flow that gets released back to the tank when you hit that high speed. You obviously want to drain off a little bit of the fuel, but you don't want to lean the motor out so much that you have a problem. And then let's see. Then I've got a little gauge that's just on a fitting there on the output. That's just so I can check it if I'm, messing with the injector, revving it up. I want to see what kind of pressure I got. So let me talk about, since I'm here, this can here, this vapor separator. What's going on with this thing? And I'm going to show you how I have this system plumbed. And it's not uncommon, although a lot of the early gassers and stuff, you saw them when they had a gas tank mounted on the front of the car, right on the front of on the grill, right? That held all the fuel, and the reason for that is it would go right into the bottom of the pump, come up, get utilized, bypassed, and it would go right back in the tank. You didn't have any external pumps or anything. I do have an electric fuel pump in this, which is in the back of the car, in the trunk. And that runs fuel up to the bottom here. Let me see if I can show that at all. So the one on the left, that's a -12 that goes to the tank. Well, to the electric pump with the tank in the back of the car. And then this other line coming off goes to the bottom of my vapor separator tank, which is just a vertical tank. There's nothing in it. It's an empty tank. I actually did put a float switch in here. That's beyond the scope of this discussion here. It's for a different reason. But so let's just look at the line here. So from the main pill, the main bypass, when the engine's running, you're off throttle or you're off idle and you're running at mid or wide open throttle, there's fuel coming through there the excess fuel that you don't want going up to the injector nozzles. So that fuel comes back here, runs up, and it dumps back into this tank. So the tank, we want to make sure that we've got plenty of fuel on the inlet port of the fuel pump. It doesn't have high suction capability, so we want to make sure that we want to make sure that we have some sort of positive pressure on the intake side. We don't want it to get low. We don't want it to cavitate and suck air. So we keep that tank filled up. When the engine is running, the electric fill pump is continuously pumping fuel in those bottom fittings. What's not getting used by the engine just goes over, runs into the bottom of that tank and fills that up. Sorry about that. The excess from your main also dumps into the tank, and then also this guy here, which is my idle bypass. So that's my idle bypass, comes down. This guy here, this is a coolant line in the way, but this guy here, it runs into the tank. So the tank is receiving excess fuel at idle. It just gets filled back in here. And then it also gets, when we're running mid to high throttle, it gets any excess fuel from the main, dumps into here. And then there's this line. This line goes back to the main fuel tank in the back of the car. As does the line from the high-speed bypass, goes back and dumps right directly in the tank in the back of the car, because we don't want any restrictions on that. So anyhow, that's kind of the overview. I do have a schematic I'm going to show in a minute, and might give you a better understanding of what's going on here. I know this could be confusing to guys that have seen it for the first time. Totally understandable. We're going to walk through it. So, okay, here we go is a schematic of what's really going on with the mechanical fuel injection. Now, there are a couple things to this system that may be slightly different than other plumbing schematics you've seen. I've added a couple things that might not be real common, and I'll explain why here in a second. So I'm going to start right off at the back here. I got a nice big pointer this time. Over here, so this is the fuel tank. It's in the back of the car. And of course I run methanol, and methanol is very hygroscopic, which means it absorbs water like nobody's business. If you leave the cap off of a tank of methanol for any length of time and it's very humid out, you'll spoil the methanol. It absorbs the moisture so quickly, it'll spoil it. It won't be work. You just dump it out. It's no good anymore. So that being said, you would normally want to make sure you would want to keep this tank sealed when you're not using it. Obviously, if you're pumping fuel out of it, it's going to create a vacuum in here, and you'll collapse the tank if you don't have a vent. Okay, so what I've done on my particular vehicle, my hot rod, so I have a 12-volt electric solenoid valve. Now this is all in the back of the car. This is the fuel cell is in the trunk area, and on the top of the fuel cell there is a port, and I have a solenoid valve just plumbed to it. It's just a small line, it doesn't need to be very big. It's like a -3, like the size of a brake line. And then I take that line and I go through the underside of the vehicle, and I just have a fitting, and I've got one of those little brass, these sintered bronze breather ports, right? It's just, dirt can't get in it, but it's free to blow air, suck air, and it's perfectly well suited for this. So anyhow, I have that solenoid valve tied into my electric fuel pump. So anytime I turn on the pump, it opens this valve so that I don't create a vacuum in here. Okay, so, and I'm giving you the basics first. I hope I'm not boring you guys all to tears, but so in my system, again, the tank is in the back. There's a reason for that. At one time, I just had, I didn't have the fuel injection the way I have it now, but I want to utilize that. It's a very nice setup. So I've got an electric fuel pump back there. It's like say a foot away from the tank, right in the back of the car. So I go through the electric fuel pump, and it's actually a pretty good sized one. Well, they advertise it flows, I don't know, some hundreds of gallons per hour or something. I don't think it really performs that well, but it's plenty sufficient for my vehicle. So these are number 12 lines, or -12s, 3/4 inch fuel line going up to the front of the vehicle. Overkill, again, if you didn't have, if you got a pump that you're pushing fuel, you really don't need that. It's a long story why it's a -12, but you can never go too small though. You always want a large fuel line, as large as reasonable. And of course, the only drawback to that is too, though, if you're gonna, like a drag car and you're launching, right, you gotta calculate, well, you don't have to calculate, but take into consideration that all this fuel is running in the direction of where you're accelerating to. So in my case, I've got like a half a gallon of fuel in this line here. So that's like what, 3.5 or almost 4 pounds maybe of fuel. So if you think about it, if you had like a 3.5 pound weight on your dashboard and you did a whole shot and launched the vehicle, that weight is going to be through the back window maybe. My only point is the fuel gets pushed back. You got to make sure you compensate for that and have a good pump on the back end here pushing it forward. Otherwise, what would happen? You'd launch, you get a little vacuum buildup, you'd lose prime on the pump, and the motor's going to bog. You're going to be out of fuel for maybe a split second or whatever. Okay, so with that, now I come in here and I go into, this is the intake side of the pump. This is my high pressure pump, that Waterman Sprint 400 pump that we talked about in an earlier segment. So in the bottom of that, I have also teed in this vapor separator, some people call it a surge tank. And the only reason for that is during the course of the operation, running the engine between idle and mid throttle, wide open throttle, I'm returning fuel back to somewhere. Well, if I return it all the way back to the fuel tank, then it's got to be pumped all the way back forward. If I have a surge tank here, I can keep it filled up, and I can make sure that I have plenty of supply of fuel down here to the suction side of my high pressure injector pump. It's just kind of an easy way to do it. Okay, so the layout I have here is, here's the tank, here's my pump, here's the electric pump, here's the high pressure injector pump. I got a surge tank, and then coming off of here, I got one line that comes right up and goes up to the barrel valve. There's two other ports. These are all connected inside the fuel pump. There's a vertical port, and then there's two off to the side. Physically, they're off to the side, but for this depiction, they're coming off the top. But that's all the same pressure that the pump is making. It's pushing it out, all those three fittings there. So one goes up, boom, goes through the main pill holder, and then what gets passed through the main pill holder goes back into the surge tank. Likewise, the high-speed bypass, when you're at wide open throttle and then the RPMs are really, really high, you determine you want to lean the fuel back a little bit, so the high speed becomes active. The pressure is high enough where it opens the high speed and it sends fuel. This is only used very seldom, so we just run that back to the tank. I don't want to have any restrictions here, because when I need the high speed, I want to make sure it bleeds off any of that real high pressure stuff. That could have been, you could really plumb this back into the surge tank if you wanted to, probably without any issues, but this is just how I have it configured on my vehicle. So there's the three outputs from your high pressure pump. Up here, I'm showing the barrel valve. It's just we talked about this before, and these would be your nozzles connected to it, all connected together. And then here's your idle bypass. So let's look at it. I'm going to change charts here. Okay, so here we are at idle. When you're at idle, the idle bypass circuit is active. So I'm showing the orange color here as being the fuel. Comes through the pump, electric pump, comes up here, goes red when it gets to high pressure, and of course it fills up this surge tank. And when I said idle bypass is active, that means we're at idle, we're pumping high pressure up here, relatively high pressure. We're not using a lot of it. Boom, it goes through this purple line, goes through the bypass, so you got circulation back into your surge pump, surge tank. Okay, so then the next one, I'm going to change slides again here. Okay, now at your mid or wide open throttle, you're accelerating still, your RPMs aren't like maxed out yet. What's going on here? So your bypass, idle bypass, is not doing anything. Remember, when we open up the barrel valve, as soon as you get off of idle a little bit, there's a couple of orifices in there that line up when you're at idle. As soon as you come off of idle and you start ramping up the fuel going to the nozzles, that circuit gets cut off. So then everything, all the pressure from your pump is going right to the barrel valve, right to the nozzles, through whatever the position your barrel valve is. This idle bypass is out of the circuit, chopped off inside the barrel valve. And a correction, I made mention in one of my earlier videos, I said when the barrel rotates, I was trying to explain how the barrel valve worked. I didn't really have any graphics or anything. It's actually called the spool that's inside the barrel valve. They call it the spool, and they can have, they can be ground with different angles on the ramp for how quickly the fuel increases through your nozzles. It can get real crazy. The one that I have in mind is just a standard one that was shipped normal. There's guys that have messed with that over the years. I don't really know a lot about that. The barrel valve I have and the spool that's in it is the one that came with it. That could be a whole research project in itself, playing with the angle of the ramp in the spool valve. It's the spool in the barrel valve itself. Okay, so I'm sorry, I get off topic really quickly. I start going down these rabbit trails. But again, it's all stuff that I'm thinking most guys would, maybe like to hear about. Okay, so this was the bypass is inactive here. The high speed is inactive, and the only thing is your main pill whatever the orifice size in this is, 60 thousandths, 80 thousandths, whatever, is draining off any fuel that you don't want to go to this direction. So think of it, if the high speed's out of the picture, the main pill is out of the picture, say that was totally closed off, what's going to happen? Whatever RPM you're at, it's going to be just pumping every stitch of fuel right up to your barrel valve and out the injector nozzles. Well, depending on the performance of the pump, the size of the pump, the volume it makes, and the pressure you're here, you may be squirting like way too much fuel into the motor. So what you do is, and I think, well, I don't know if it's typical, but what I've seen is most of these pumps when they do flow tests on these pumps. If you buy a pump, you'll get a sheet with it that'll have it flowed at usually 1,000 RPM, 2,000, 4,000, and that's pump speed. So for engine RPM, that'd be 2,000 RPM, 4,000 RPM, 8,000 RPM, and it gives you the capacity in gallons per minute. And the only reason I mentioned it, that's usually a lot more than you would ever use you would size this sufficiently large enough so you would never have to use it all for your motor. So what happens? So you're pressing this up, and say you're at a, 80 PSI, you can increase the pill here, and what that does is, if you make this pill orifice bigger, what happens? Well, you got less restriction on this line, so that means less is going to go there, and less is going to go up to your barrel valve, and a little bit more is going to go back to your surge tank. It's just the opposite of a carburetor. If you have a carburetor, the fuel that you're putting into the engine goes through the jet, right? The main jet. And if you want it richer, you put a bigger jet in it. It's just the opposite here, because we're not metering the line of fuel that's going to the injectors. We are metering the line that bypasses the injectors. So for instance, if we wanted to make this a little richer, we're wide open throttle, we're looking at our wideband, and it's like, it's running a little too lean. I think I want to be a little bit safer and put more fuel into it. You would make this main pill, you would make this smaller diameter orifice. You put a smaller jet in it. So that smaller jet is going to restrict this line more, and it's going to force more pressure and volume up this line to your injector nozzles. Okay, that wore me out. Let's go to the next one. Okay, wide open throttle, high RPM, you're maxed out, you're winding tight. The high speed goes active. Boom, you hit a certain pressure here, and again, it's there's some guys that don't run these at all, but if you really want to tailor your fuel delivery system to your engine, when you get a really high RPM, the fuel demand curve falls off a little bit. And so what happens, if you really want to maintain the maximum horsepower, what you need to do is drop the fuel back a little bit. You need to reduce some of the fuel that's going into the engine. Now, granted, it's a lot. When you're wide open throttle, you were cranking some fuel through there. But when you're at max RPM, and you got to determine that, you're running a 7,500 RPM drag motor, or maybe you're running a 9,500 RPM drag motor, or whatever it's in, offshore boat racer, offshore racer or something. Anyhow, when you get to that high pressure, and like I said, I think mine, I believe I might have mentioned it, is set at about 100 or 95 PSI here. So when it hits that pressure, there's, again, a poppet and a spring. And I'm going to show you in the garage. I think I want to take these apart and show you guys what they look like. It's really hard to, if you're like me, I want to see this stuff. And that makes it that much easier to understand that way. Okay, so high speed's active. We hit that high pressure. It opens up, it pushes up against a spring and a poppet, boom, it opens it up, and then it goes through another little jet in here, another little pill, and they're physically the same outside dimensions as the same ones you'd use for the main. Now, obviously, the orifice sizes are all different, but the only reason I say that is it's the same kind of a jet, right? Like one would fit, you know, you could use the same jet in either one of these if that's all you had. So now the size of it is going to be probably pretty small. I mean, you don't want to bleed off a ton of fuel and over lean your motor, and because what happens, right? You got an internal combustion engine, you're winding it tight, you got a lot of fire going on in the combustion chamber, and now all of a sudden you take the fuel away, but you're still pumping just as much oxidizer in there, air, right? So what's going to happen? It's going to consume something as fuel. Well, what would that be? Well, the easiest thing to start picking off of fuel is the top of the piston. It's aluminum, it's soft, it reacts easily. Then you start melting stuff. So obviously, you know, this is a cautionary area. I wouldn't play with a high-speed bypass too much until you're really sure what you got. Maybe you've got a wideband monitor. You can see what the exhaust is looking like, you know, how much unburned fuel you have, or you know, how much excess fuel that you have in the exhaust. That can help you pick this a little bit. All right, so those all, and that dumps back to the fuel tank. I probably lost a lot of guys by this point. Goes right back to the initial. Again, this is how I have my system configured. Some guys don't even have a fuel tank in the back. It's up in the front of the vehicle. The surge tank is basically the fuel tank. You know, they got an opening over here, and this comes right in and goes into the pump, and it just keeps circulating around, with the exception of what's going to the barrel valve. And that's okay. You know, they did that on gassers and stuff for many, many years. Mine's a door slammer. I know I had a couple people that mentioned that they wanted to walk around the car and see what I've got. And I'll do that here in one of these videos. So one of there's a couple things I did want to go back, and I don't know, maybe I shouldn't do it in this order, but I'm going to go through it anyways. I had made a couple comments in the previous videos, and I had people mention some errors that I made. So when I was measuring the distance between the shafts on the fuel injection manifold itself, I had said something like you need to take half of the radius and add them together. Well, of course, that was wrong. Half of the diameter of each shaft is the radius, and if both shafts are the same diameter, then half of the radius of one is the same as half of the diameter of one. That radius is the same as the other radius. You add them together for the diameter, and you subtract that from that outside to outside distance that you measure, and that gives you the center to center distance of the throttle shafts. So I hope I didn't confuse anybody there. I also had a couple of comments about injectors, and actually Spud Miller looked at one of my videos, and he made a comment to me which was a very positive one. Says to be cautious that when you're talking about injector nozzles, the numbering system that's on them. So Enderle and Crowder use a decimal system that's based on the actual orifice size. For instance, I think I got 33s in my car right now, in my engine. They're probably a little fat, probably a little too big. But Crowder and Enderle actually stamp on their nozzles the number that's stamped on them is the size of the orifice diameter. So if it says 35, it's 0.035 inches, right? However, Hilborn uses a flow number, and that's in gallons per minute at 30 psi. So I know that's a little confusing, but that's how they came up with that. So if you've got a Hilborn nozzle that's stamped 35, it means it's 0.35 gallons per minute when you're flowing at a pressure of 30 psi. And then Kinsler is in pounds per hour. So the only reason I bring that up is I know that there's a whole, you go to a swap meter, you go whatever, you see stuff online, you want to buy a set of nozzles, you think are right, you just got to be really cautious. Now I did see one somewhere, it may have been in the Kinsler catalog, I'm not sure, but there was an actual chart in there, and it showed which nozzles were equivalent to each other from the different manufacturers, the different brands. I'll see if I can find it. If so, maybe I'll pop it up on the screen in one of these videos. But just be careful with that. So again, I think I probably lost most of my viewers with this one, but we're going to jump into the next section. I'm going to show you the hardware we're talking about. We're going to look at the main can, the main jet holder, pill holder. Then we're going to look at the high-speed bypass, and then I want to start wrapping it up a little bit, and we'll start talking about the fuel delivery based on your volumetric efficiency, which is a key thing, right? When your engine, the faster and faster your engine spins, the less likely it is to be able to completely fill the cylinder with that volume of air, right? Because there is restrictions. After you get through to a certain RPM, the restrictions become more and more noticeable, and they make obviously greater effect. And a good way to think of that is like, well, so what happens if your daily driver, right? If you've got the engine sitting there running and the throttle's closed, it's just idling, right? It's creating like a bunch of manifold vacuum. Why is it creating a vacuum? Because it can't fill the cylinders, right? So it's trying. So it's got a bunch of vacuum so the volumetric efficiency at an idle is going to be really, really low. Same. That's why guys, port the snot out of their heads. You want to unshroud the valves as much as possible, make the ports as big as possible. That's so you get that huge flow of air. It's unimpeded or less impeded when you're cranking on high RPMs. When you're cranking out the big RPMs, you want to be able to fill that cylinder quickly, expel it, and fill it again. And it happens really fast. And the less restriction you have, the more power you're going to make, because you can cram more air into the motor, and you'll be able to put more fuel in it, obviously. So when you do that, you're going to be making more power. And that's why you see that fuel curve that I talked about, where, excuse me, where the fuel required tapers off with RPM. That's based on the loss of volumetric efficiency. And of course, if you got a blower, that compensates for that. Okay, that's all I got for now. Okay, so in this segment, I want to talk about the continuation of the fuel management system. We talked about the idle bypass or secondary bypass, the can. We talked about the barrel valve, and now we're going to talk about the other two major components to tailor the fuel that you're delivering to your ejector nozzles. And the first one, obviously, is your main jet holder, main pill holder. And I think I've already explained this in probably one of the earlier segments, but so this restricts the flow of fuel that goes back to the tank and basically forces your pressure up to the barrel valve. So if you want to reduce some of the fuel, which you do, obviously, because the pump is oversized, so you would adjust that leakage back to the tank with your main jet. And again, unlike a carburetor where you would, if you wanted to richen up the fuel mixture, you'd put a bigger jet in it. With this system, you're actually, the jet or the pill is on the return going back to the tank. So if you wanted to richen it up, you'd make this smaller. So let's take a look inside here. This, just like the other cans has an arrow for the flow of fuel going that way, so the pump is here. And you'll notice here, I'm mentioning it right now, you'll notice here that this fitting on this side is a little different than that. This is a 6AN, that's all the rest of the fittings that we've been using on this system use. On this side, it's a -6, but they call it a -6 ORB, which means O-ring base, I guess, or O-ring boss, I'm sorry. So it doesn't have the flare on the tip of it. And this screws right into the fuel side of the fuel pump. I mean, you could put it on a line. It doesn't really matter where you put it too much, right? But if you put it right on the pump, it uses this type of fitting. Now, there are adapters that go from the -6 ORB to a regular one, a regular -6AN, if you wanted to put it like in line between two hoses or something. But okay, so anyhow, that's enough about that. And obviously it just has a rubber O-ring. You screw it in until it seals against the O-ring. So let's take a look inside. I've already cracked it loose with a wrench. And just like the idle bypass, it has a spring. And if I can get it out of there, and I'm losing all my... there it is. So it has a poppet, and this actually has 2 spacers in there for the spring, increase the spring pressure a little bit. And actually I see one of those fatter spacers in there as well. So that's just to adjust the spring pressure. Now, so the only reason there's spring pressure on this, it's very light. This one is very light. The only reason there's a spring in here for this is, and a poppet, is so that when you're first starting the engine, say all the lines are dry, you haven't run it for a while, or you've drained the fuel out of it or whatever. So all there is air in the line going all the way up to the barrel valve and to the nozzle. So this will hold back the return, close it off, so that when you're spinning, you're starting the engine, the pump's moving really slow. You're able to prime the system. It pushes a little bit of fuel up, gets it up into your barrel valve. If you didn't have this spring and poppet in here, what would happen? You'd have the drain back going to the tank. It would take you a lot of spinning before you could overcome that hole there, right? Because you're moving really slow RPM when you're cranking the motor over. So anyhow, that's all that's for. It's just basically to help you get prime on the system up to the barrel valve. Of course, once it's running, your pump is making at idle maybe 20 psi or something like that. When you start winding it up, it gets up to 80, 90, 100, depending on the pump size and the size of the nozzle, or the size of this pill in here, this jet. So anyhow, then I'm losing this stuff already. Okay, so I'm going to set this down here, and let's take a look at the, and of course inside the can here is just a seat for that poppet to fit into. So let's take a look at this guy. This is the business end of it, right? So there is your main, we'll call it a main jet. That just fits in there. It's a little rubber O-ring. And I want to show you how you get those things out. It won't come out of there. You can't just pull it out of there. And these are brass. They're machined to real tight tolerances. They're in thousandths of an inch. I'm not really sure which size this is. We'll look at it in a second. But I just wanted to caution you, don't put pliers on it and try and pull that out of there. The best thing to do is take something very soft, because this is brass. It's really soft. You want to use something softer than brass to kind of nudge it out of there. And so what I do is I've got this little stick here, right? And I thought I could use a pencil. One time a pencil's too big to go in there. So my suggestion is, next time you go to Mr. Cheese, Great Wall of China, steal an extra set of chopsticks from him. You can cut the end off and it works perfect in there. So all right, that's enough of that. So then you just take that and you just tap the end of it a little bit. Oh, and it just fell out on the floor, of course. And it's gone. It is gone. Here it is. So that wasn't a very good demonstration of being cautious, was it? Anyway, so here it is. Now this one here, I need to actually clean these up again. So this is, if you can see it in there, this is a 70, looks like a 75 thousandths. I'm not really sure. Huh. Yes, I believe that's this. All right, so I'll have to clean that up a little bit and take a better look at that. It's either 70 or 75, and it's got some residue on there. Remember I talked about using top oil in that. It leaves a little bit of a gooey residue, and so I might actually clean this up and before I put it back together to run. But let me blow that piece out of there. Yeah, this is a 75 thousandths. I can see that now. So if you wanted to make it richer on the the mid and top end, you would put a smaller jet in there, smaller pill, and you can see it just has this little butyl rubber O-ring on the edge to make sure it's sealed. So what you'll end up with, I've got this little bag of parts that I keep around, and what I have, and you got a system like this, you'll have it, or we'll end up with it before you're done. So I got a little bag of, not many, I mean, there's real fancy pill holders and stuff, and you can buy these kits that have, a large number of pills. These are all original Crowders, but by the looks of it, Crowder. So there's a 60, 55, and a lot of guys just go in, like 5 thousandths increments. Although I do want you to be sure to know that very small, I mean, surprisingly small variation in the orifice makes a really big difference. I mean, it can make a big difference because you're pushing you got a lot of pressure behind there, a lot of fuel going through it. So, 5 thousandths at a time is probably the most you'd want to go, unless you got to make a huge jump. So anyhow, I've got these ranging, looks like from about 50 to 70, 75 or so. There's a 70. That's another 60. So anyhow, you'll end up with a little package like that to play with when you're doing your tune. And in my little bag here, I just want to show you. Of course, I've got some extra springs and poppet and some those little rubber O-rings. But here's one thing I wanted to show you that I keep in here. So this is my original settings, my original tune that I used. My main between 75 and 80. We've got a 75. I just looked at and showed it to you. The idle. Actually, this is different because right now I don't have a jet in there at all. Of course, this is a really big number. I mean, that's a really big jet. 18 to 20 psi. The high speed, 70, 75 psi. I actually thought it was bigger than that, but okay, I'll have to investigate that. This was the original tune card that I got, when I first got the thing. So I've changed it some since then. That's nothing. Okay, and this was when I sent one of my original pumps in. They just sent it back with a yellow tag. Flows bad. It says needs to be clearanced, and I can't even read the run of it. This apparently has a lot of run out. So anyways, I got a new pump. Actually, I'm on my second pump. And then this guy here, to be honest with you, I haven't looked at this stuff for a while, so it's a surprise to me. This is some spacers for the cam button for the drive. Okay, so anyhow, that's what it looks like. Of course, the pill, you put it in. You just push it in like that. You probably need to maybe put a little dab of some lubricant on there, some silicone or something. This is actually going back in pretty hard. And then, actually, you know why, too? I'm putting it in backwards. So, it goes in like this. There it is. Okay. So, yeah, that's correct, because the spring goes on it like that. And then, of course, we talked about the very light spring pressure here. There's a little couple of spacers in there to make it a little tighter. Now you can measure this just like we did on the idle bypass. You can use your pressure gauge. You can use your leak down tester. Just look at the right hand gauge and see what pressure this opens up at. But this will be very light. So anyhow, so that's your main jet holder. This guy. Now this guy is a little different. This is the high-speed bypass. And again, it's got the -6 ORB O-ring base to it. Let me see. There's the arrow for direction of flow, and it even says high speed on it. So same with this thing. It just screws apart. Now this guy is kind of interesting. Now remember, we only use the high speed when you're at really high RPM. When you set this so when the pressure hits a certain level, usually like 100 psi, 90 psi, 100. Originally this was set at 90. What did we? The original card I think did 75 to 85 or something like that. But this is kind of interesting. This actually has a screw. There's a ball in there, and I don't think you'll be able to see it, but it has a ball instead of a poppet type thing. There's just a round steel ball and a spring, and this is threaded inside. So what you do is we take a really wide bladed, you'd want to be careful using a screwdriver, but I have to be honest with you, I have used it before, but a wide bladed screwdriver to fit in there because it's brass, you don't want to tear it up, and you can adjust that. So what you would do is put your gauge on here, your leak down tester, set the pressure, and of course the air is going to be blowing through here. I mean, do it just like this with it open, right? And then while you're watching, you can stick your screwdriver in there and turn it, tighten it, loosen it, whatever you need to do until the pressure that the ball actually opens up, opens and starts letting air out. So you just adjust it with a screwdriver, and then of course this spring, which is a real stout spring, that just goes, when that goes together, that just holds that position so it can't back out, right? It just holds it up there in the threads. So now this also has a jet. I mean, you wouldn't want to be, going down the track, going on the straightaways, up on a plane, whatever you're running your motor in, wide open throttle, and get to the high RPM setting where you need to start trimming your fuel back. And of course, we talked about that. That's based on your volumetric efficiency of the engine. So you don't want to just hit a certain pressure and bang, unload all the fuel, unload a lot of fuel. You'll lean the motor out way too much, and especially being at max RPM, you won't have a very long survivability of the motor. If you got it maxed out, now you're taking too much fuel away. So you put a jet in here. Now you got to be really careful with this guy too. I'm going to do the same thing. We'll tap this out. I'll try not to lose this one this time. All right, so this guy here, this is an 80. It's actually bigger than I remembered, but this is an 80 in here. But again, that only kicks in when you're max RPM, real high RPM. So of course your pump is just screaming fuel. It's it's putting a lot of fuel out there. So anyhow, this just goes back in like that. Spring fits over that nicely. That just goes back into the can and screw it together. And then these, I had them on my pump. I think you saw it in the last little segment I did. Screw into the sides of the fuel pump. All three ports are the output of the pump, so they're all seeing the same pressure. It's all equalized between them. So that's those components. So I know I've had a few people ask me, well, what size bypass do you use? What do you use for your cycle? That's where the rub comes in. Now, so I've got a treat, if you will, for those of you, rather than to get into huge discussion about how you measure air and humidity, and the air density, and how you adjust for that. I mean, it's all different. Every time there's a change in the weather, the altitude you're racing at, it changes. It's very dynamic. So I'm going to take you here in one of these upcoming segments. I'm going to show you something that'll really, really, really help you without having to know how to do all these calculations between, calculate pounds of air and that kind of stuff. So that'll be coming up in another segment. And I think that's all I have for this one here. You kind of get the idea. There's not a lot to it. They're pretty simple. They're very simple devices. Crude in some people's eyes, but again, when you get them dialed in and get them really close, you'll end up making a log usually if you're a racer. If you're drag racing, however whether it's just a weekend warrior thing for fun with your buddies, or even if you're more serious, you're gonna have a log book. And you'll record things like, the air temperature and the density of the air, and it's like keep a track of that. And then what you had in for a main, what you had in for your high-speed bypass, and how you had your barrel valve adjusted to it. And actually, that only really is going to bother you much at an idle anyhow. So, but these would be the key guys right here. So you keep a log of that, so then that you have a record. You can go back and say, well, the last time I was at this track and it was 80 degrees outside, it was 52% relative humidity. It was here, this was really close. Let's put it 80 in here for the main tonight. Okay, so you try that, you make a pass or two, and then you might have to adjust it there from there. Anyhow, there's a lot to it, but once you get it running good, I mean, it's badass. You'll have a good time with it. You'll be very competitive with them as well. Again, mine is just mine's just a hot rod. I've been building it for years, and it's, hasn't really seen any track time. And I'm getting older, but I'm going to get there. and I don't really know why I started doing this video, other than I got a little frustrated, and I thought, I didn't really find anything that was useful on the internet. And so I thought, well, what the hell, I'll take a hack at it. And I've got a number of views. It's dwindling off. I'm sure the guys that are really interested in this were bored and long gone by now. But anyways, that's what I have on this. I'm not sure if I'm going to do it this time, but I got another couple of little videos I'm going to show it. Okay, that's all I got for today with the fuel management system. Okay, so that's it for this segment, this part 4. Yeah, I'm losing track. I hope you found the information useful. I tried to show you what I have. Again, I'm not an expert on this stuff, but I think a lot of guys would just like to see the components and maybe give you a little bit better understanding of how they work. I am going to, on the next part, talk about how to actually tune. And I have to tell you, I'm going to cheat a little bit because I've got some I found some software online from a vendor who actually he and I have communicated back and forth a few times while I've been doing this this little discussion on constant flow injection. But it's software to help you tune the motor, and I'll run through that, show you how to log on, or what you need to do to get the permission to log on, and it'll save you a lot of headache doing calculations, figuring out mass, air mass, and stuff like that. So I'll be doing that. That'll be part 5. And I think I also want to show you the wideband that I use in the exhaust headers. That helps with the tuning, obviously. You know what kind of what unburned fuel, if any, you have. Basically, how the stoichiometric balance that you have is working out for you. Do you burn all the fuel, or you still have residual? And then I got a little section I want to do. We were fortunate enough to visit the Gator Nationals were a couple of weeks ago. I was fortunate enough to tag up with a friend of the family's who actually works for Paul Lee Racing. And we're going to take a look at the FTI funny car inside we got inside their pits. and he walked us through the trailer a little bit, just real briefly. It's kind of fun. You know, it's just interesting to see this stuff. And of course, we had a great lunch on them, which is always good. But anyway, if you found this interesting, you learn anything, click the link in the bottom. Help me out a little bit. All right, thanks.